Hello there. In this video we're going to use the inscribed angle theorem and other things about a triangle to try to figure out this unknown arc length over here. Now just to specify, this arc here is the 40 and this part here is the x. It's not extending out to more than that. This specifies just this region that it's immediately next to. No more, no less. So I know that this arc up here is 40. I want to figure out something that opens up to it. We're just going to start by jotting down things that we know are true and see where that leads us. So over here we get an inscribed angle that's opening up to that 40-degree arc. So that angle right down there, that has to be 20 degrees because it needs to be half of that arc. And we proved one case of that together in class, and the part of the homework was for you to do the other couple of cases. But any inscribed angle opening up to it is going to be half it. So actually over here, there's another one that's 20 degrees too. And we could put that one on there too. But it may not be strictly necessary. So remember, ultimately I'm trying to get what this x here is. I know that there's a 90-degree angle in there. But this is not a central angle, so this being 90 doesn't mean that this has to be 90. Yeah, maybe it is, but it doesn't have to be. It's not a central angle. Central angle would somehow be down here. So I got to use some other stuff. Well, I know that's 90. I have a triangle up here, so that up there's got to be 70, because we have a right triangle. So we know that that's 70. Same thing's going to be over here. That's 70. And that angle of 70 opens up down to this big one. So you can see how we sort of jump around this circle. The big angle down on the outside, that's got to be double it, because 70 is an inscribed angle, so that's a 140-degree arc down on the bottom. Now we've used 40 on the top, 140 on the bottom, so that's 180. That leaves us 180 left to play with for both this region and this region. But the whole trick is that these regions here, those arcs, those have to be the same. And that's because these chords are the same length, because these triangles here and here are congruent through side, angle, side. We could also do, a lot of things. We could actually do angle, angle, side. We could do angle, side, angle. We've got basically anything that we want here because we know tons of angles and sides. But those are the same length, and another thing that we proved is if chords are the same length, that means that the arcs also have to be the same length, so that's also x. So the 40, the 140, the x and the x has to equal 360. That means that 2 times the arc of x has to equal 180, so arc x by itself is simply 90 degrees right over here. Alright, now there's other ways that we'll be able to do this in the future using information about intersecting chords, but using just inscribed angles. We kind of proved one of these theorems here. We were able to bounce around this circle, and we also used applications about knowing various side lengths and what had to be the same. Thanks for watching. Character and Scholarship for Life.